Hi, everybody. Welcome back. We're going to cover the science behind our amazing abilities to create, to grow, um, to communicate, all sorts of things. Okay. So we're just going to jump right into it. I'm going to go ahead and do a share screen. And we're going to play some of this video. This is a very long video, so we're going to actually jump through bits and pieces of it. We're not going to take up an entire 2 hours here, I promise. And this is a legitimate scientist named Michael Levin. And he's going to explain through scientific data that we are all collective intelligences.
It's handling all of its metabolic, physiological, behavioral, and morphological needs at the level of a single cell. And so this is the sort of thing that we are all made of. We are all made of single cells that used to be independent organisms. And so it really highlights developmental biology as perhaps the most amazing of the sciences in the following way. We all made this journey across the Cartesian cut. We all start life as this, basically a quiescent oocyte, a single cell that's a collection of chemicals, most of which aren't doing very much at the moment. And then, so someone could look at that and say, okay, this is what people call just physics, right? This is physics and chemistry, and that's it. And then eventually, you get to be something like this. You get to be this, or maybe something like this, but you become a centralized, very complex cognitive system that might make claims about, hey, I'm not a machine. I'm a true mind, whatever that is, and so on. But that journey is slow and gradual. So we all start life this way, and then slowly but surely, the process that goes from physics to mind is basically embryogenesis. And for that reason, we really need to dig in and understand what happens during this process, because there really is no magical stage where some lightning bolt comes down and there's this bright line and says, boom, now you're no longer physics, now you are a cognitive system. There's no such place. It's a gradual, slow process. So we need to understand that. So the main points that I'm going to get across, I hope, today are these. First of all, that biology uses a multi-scale competency architecture, which is basically a nested set of problem solvers in various problem spaces that all have their own agendas, and that navigation policies and competencies in these spaces are really fundamental to understanding the emergence of mind and the functionality of mind. I'm going to argue that in a sense, goal-directedness is a really powerful invariant for recognizing, communicating, building, and relating to really unconventional agents, really novel kinds of things. And then I'll trot out a specific cognitive boundary model for the scaling of cognition. And about a third of the talk is going to be using a very specific example, understanding morphogenesis as the collective intelligence of cells navigating a particular kind of problem space, specifically anatomical morphospace. And I'll talk about electrical networks, which are the mechanisms by which that cognitive scaling takes place. And it's important because I'm going to say a lot of things that sound conceptual or philosophical, but the key thing to realize is that all of these lead to very practical empirical predictions, which we've been working on for over 20 years, and they've led to all kinds of new discoveries in terms of new capabilities, and what some of which are hitting biomedicine now in terms of biotech and things like that. So this is not just philosophy. These are really practical kinds of things to think about. And towards the end, we're going to think about this idea that the competency of life at all scales enables a kind of synthetic bioengineering that provides a massively large option space for new bodies and new minds that don't have standard evolutionary backstories. And that's going to have implications for a lot of things, including ethics. So we'll touch on that at the end. So let's start thinking about single cells, of which we are all made. Here are some cells. So this thing is a single cell. Okay, look at the let's just think about the spatial competencies. Look at the amazing order that was created by a single cell. This is not a misprint. This is a correct scale. This thing is huge, about 10 centimeters. This whole thing is a single cell. This is an alga called acetabularia. It's got some roots, it's got a stalk, it's got a cap, one nucleus. The whole thing is one cell. And so we start already understanding that single cells are not kind of some simplistic building block. They have some interesting morphological competencies. They also have behavioral competencies. So what you see here, let me just talk over this first. This is an experiment with a slime mold known as Physarum polycephalum. It's placed in the middle. That's the yellow portion. The white discs above and below are glass discs. They're completely inert. They have no food residue on them or anything like that. It's just glass. And the whole thing is sitting on a flat agar dish. And what happens is and this is reliable. This happens all the time. So it grows. This Physarum grows. And then what it will do is it will reliably choose to go to the heavier, to the larger mass. Okay. It always goes for the 3 over the 1. Unless you disturb it in various ways. And so what's happening here is that during the first few hours here, you can see it just kind of grows in every direction. And what it's doing is it's slowly tugging on the medium. It has it's a kind of biomechanical effect that's almost a kind of sonar where it tugs on the medium and it reads back very kind of minute differences in vibration induced by the strain angle that these glass discs are putting on the agar. So it can tell the difference at a distance of centimeters. It can tell the difference between 3 discs and 1, and then it kind of makes a decision and goes. After it's processed that information, boom, there it goes. So the interesting thing about this life form is that here the behavior and the morphology are intimately linked. So this creature, and again, this is just one cell. This whole thing is one cell. This creature's behavior is morphological change, right? This is an example of evolution slowly pivoting from problems in morphological space to behavioral space, and we'll get to that momentarily. So the next thing I want to do for a couple of minutes is to really kind of broaden our idea of what agents are and the continuity between different kinds of agents. And then we'll talk about some examples and then we'll move from there. So this is kind of the old classical picture of agents. This is a famous painting of Adam naming the animals in the Garden of Eden. And the reason this is important because this is really this kind of view pervades a lot of scientific research, which is this idea that what we're dealing with are discrete, separate natural kinds. You've got, people will do experiments and they will say, here is a rat, here is the human brain, and so on. And we really need to start breaking that down because both on an evolutionary timescale and on a developmental timescale, these things very slowly morph into all kinds of other systems with all kinds of other properties, and it really becomes important to ask when and how do these properties appear. And so let's just talk about some examples where things break down. This is a caterpillar. This is a kind of soft-bodied creature that needs to crawl around and chew plants. And what it has to turn into is a hard-bodied creature that has to fly and drink nectar. And because those take very different kinds of controllers to operate during this process of metamorphosis, when the caterpillar turns into a moth or butterfly, the brain is largely liquefied. Most of the connections are broken down, many cells die, and then a new brain with a new structure is rebuilt. One amazing thing is that, and you can read more about this here, is that actually memories are conserved. So memories persist. This incredible remodeling of the substrate. So that's pretty incredible. It has some implications for theories of memory that rely on fine-tuning synaptic connections and things like that. Also, you can think about what it is. I mean, it's one thing in philosophy 101 to think about what's it like to be a caterpillar or what's it like to be a butterfly. Let's go to the next level and ask ourselves, what's it like to be a caterpillar becoming a butterfly, right? What's it like to be a cognitive agent during the time that your brain is literally reformed to be a completely different kind of agent? So these kind of changes happen not only on evolutionary timescales, but also on the timescales of a living individual. Here's another example. These are planaria, so these are flatworms. They have a couple of interesting properties, which we'll talk about more shortly. One of them is that if you cut them into pieces, they regenerate. So each piece of the worm regenerates exactly what's missing, including the brain, and they do have a centralized brain. But the other thing is they're fairly smart. You can train them. And so and this was discovered in the 60s by McConnell, but we did it more recently using modern techniques. If you train a worm to recognize this kind of laser etched pattern as the place where they get their food, you then cut off their heads, you take the tail sits there doing nothing for about 8 or 9 days. It regrows a new brain. Once it regrows a new brain, now it could start to exhibit behavior. And then you find out that they actually remember the original information. And so what you can see is that information is moving from the brain during learning, presumably stored throughout the body in some fashion. We don't know how or where. Then when the new brain forms, that information is imprinted back onto the new brain so that you can see behavior. So the movement, so here you see an example where two things that are tightly linked are morphological memory, so the ability to restore the correct worm, with behavioral memory, which is things that you've learned during your lifetime, and the movement of that memory through tissue, right? The imprinting of the results of learning from various kinds of tissues onto a new brain. So the plasticity is kind of amazing. And it also exists in vertebrates. So here's an example. This is a tadpole. You'll see here's the brain, here are some nostrils, there's the mouth, there's the gut, here's the spinal cord and the tail. And what you'll see is that there's an eye that we induced on the tail, and we'll talk later about how that can happen. The eye induced on the tail, and what you'll see is we also engineered it so that there are no eyes in the primary head where they belong. So the only eye that this animal has is on its tail. And we just, in this case, it was just surgical. We just basically took the eye primordium and the early cells that are going to make an eye, and we just stuck them on the tail. So there's the tail. And what we find out using this machine that can test and train these animals for different kinds of behaviors, what you find out is that these animals can see quite well. They can see and learn in behavioral visual behavioral trials. And so this eye, by the way, does not connect to the brain. It makes an optic nerve that comes out, starts looking around. Sometimes it hits the spinal cord, sometimes into the gut, but it does not go to the brain. And this brain, which evolved for millions of years to expect visual input from these two specific areas, now is able to say, there's this weird itchy patch of tissue on my tail. There seems to be some kind of signal coming from that through my spinal cord. No problem. I can recognize that as visual data and learn to behave accordingly. No multi-generational long-term adaptation needed. It happens in one set of offspring. So the plasticity here is amazing. And we can talk later about the implications of that for evolution. The fact that these kind of competencies really buffer the negative effects of mutation. There's a lot to be said about that. But that's, we're starting to get an idea for these different components. If you're a bunch of cells and you suddenly find yourselves next to muscle instead of next to the brain where you belong, you can still figure out how to make an eye. And if you don't find the optic tectum, you can connect the optic nerve somewhere else. So this notion of play the hand you're dealt, which is basically to have to figure out where you are, what you're doing, what your affordances are on the fly, and you can't really count on where you thought you were going to be, is important. So what biology makes use of is this multi-scale competency architecture. Not only are we a set of nested dolls structurally, that part's kind of obvious. What's less obvious is that at each of these levels, all the way up through the swarm and beyond, each of these levels is a problem-solving competent agent. They solve problems in various spaces. It is not just whole animals that do it, but in fact, all of the components do it. And what do I mean by other spaces? Well, there's the familiar notion of behavior, which is clever things that organisms do by moving around in three-dimensional space. But there are other spaces like transcriptional space, so the space of possible gene expressions, anatomical morphospace, or the space of all the possible geometric layouts of a particular structure. This is what we're going to focus on for most of today. Or physiological space, which is the space of different physiological states. And the thing is that when we're very good at many creatures are good at recognizing intelligence in this kind of space. So medium-sized objects moving at medium speeds in our visual field, we're good at learning the difference between rocks and cats and various other things, where we're good at estimating intelligence. We are terrible at estimating intelligence in other spaces because we don't have a training set. We normally don't perceive them. And imagine if you were born to have an immediate sense, the way that we have with vision, you had an immediate sense of your blood chemistry and all the clever things that your pancreas and your other organs were doing to maintain that despite various insults and so on. You'd have a much better idea of what competency in a physiological space looks like. So,
okay, so we're going to bump ahead now. I'm going to let this load for a moment, but I just want to skip through a little bit of this, and I will provide you the link to this video if you want to watch it in its entirety, because it is a lot to wrap your mind around. but it is very interesting too, what they have learned and understood about all cells having some sense of DNA memory and um, some level of a consciousness. I don't know why I can't speak right today. So I was trying to get to the part about the twins. Okay, bear with me just for a moment. Okay, I think this is where we want to be right here. Let's see. Okay, well, we'll just back it up here and go with it. About right there. Like I said, I don't want to make this one too long of a video because I know that a lot of the science part of stuff can be really mentally exhausting and challenging for people sometimes. I just want to show you that there is scientific evidence out there for how we can grow our limbs back. We can rejuvenate an organ if necessary. I mean, there's literally no limit to what we can do if we understand how to use our thought, our focus, our emotion, our visualization on a specific modality or a specific outcome. There is no limit to what we can do for ourselves or anything else or anybody else.
These complex interfaces at various levels with each other. So if I imagine one organism with many levels of many interface levels, and then another peer with many interface levels, do they have complex levels of interaction? I wish you could see my hands so I could paint a picture, but I hope that's clear.
Yeah, I'm not sure if I've got the whole question, but one thing I can do is I can let me I'll go back to sharing the screen just for a moment. I want to show you one example of hold on, this isn't the slide. Hang on, just one second. I can skip slide. Yeah, here we go. Yeah, so I want to show you a quick example of how the scaling happens, and maybe that'll help. The thing that scales up with cells, and it's not just bioelectrics, it's a number of pathways. The thing that scales up is two things. There's a kind of mind meld, which I'll show you momentarily, and then there's the scaling of stress. So one of the important things about becoming a larger scale intelligence is that the local stresses of individual subunits, the way I define stress is that error function, that delta between your homeostatic set point and wherever you are now. So that thing that drives you to keep going through that loop to reduce that error. You have to start enlarging that stress by sharing it with your neighbors. And you can sort of think about, if you tell me what you're stressed out about, I can immediately tell your level of cognitive sophistication. So if you're stressed out about the local level of glucose and that's it, you're probably bacterium. But if you're stressed about the financial markets over the next 100 years, you're probably a human, and then everywhere in between you can put something else. So here's how you scale cognition with cells. Here's a typical scenario. Here are two cells. This cell secretes some kind of signaling molecule, and it swims over and it hits a receptor on this cell. This cell, it's very easy for this cell to determine that this signal came from the outside. And so the boundary between them, the boundary of the self between them is very strong, because it's very clear to the cell that it came from the outside. It can ignore it. It can whatever. It can do whatever it wants. Now imagine what happens when these two cells are connected by gap junctions. Gap junctions are magic in the following way. because they connect directly internally to the milieu of the two cells. Let's say that this cell was there was some event that happened. Let's say it got poked or something happened, and there's a calcium flux. And now here's this calcium flux, and this small signaling molecule diffuses over into this gap junctionally connected cell. Whereas before, this cell could easily tell that, hey, that's not my information, that's my neighbor's information, and I may or may not do anything about it. This cell now has that same information internally. These gap junctions do not preserve ownership. In fact, they wipe ownership of memory information. So when this calcium gets here, this cell, which also uses calcium for exactly the same memory, cannot tell that this is now a trace of somebody else's experience. Okay, so it basically wipes that strong identity distinction between the two cells. They share all of the key memories. Once you share your key memories with someone, it's like a mind meld. It becomes very difficult to keep individual identities, because now something that happens over here is felt over here by this cell, and this goes, of course, in the bigger network that just scales up and up. So it erases the individual identities and enables this larger unit to have more computational capacity, but physically it cannot avoid now being able to respond to things that happen somewhere else. So the memories that now it has, it's a false memory as far as this cell is concerned, but it's absolutely a veridical memory as far as the new individual, the new collective individual is concerned. And so that memory wiping property helps to build larger individuals. And of course, the other thing it can't do is it can't defect. So if you're this cell and you want to do something nasty to your neighbor, you can't, because whatever you do immediately and directly comes back to you. It's just impossible to defect. So that forces cooperation. So that kind of process, and we still know very little about it. I mean, we're doing a lot of work on this, but that scaling process of connecting into these electrical networks with these very special elements that are direct connections tends to scale the individual, and then sometimes that can fall apart too. But that's where the scaling comes from. Does that help?
That's where the term "do unto others as you would have them do unto you" comes from.
Help at all?
Yeah, I really think it does. Can I have a quick note about how the gap junction comes about? Did you say that was just this type of cell, or like what is the difference between the top and the bottom picture that wasn't fully clear?
Yeah, well, simply that gap junction is something that was discovered by evolution at the beginning of the Metazoa, and it's a protein. It's a collection of proteins that make these little barrels that they're like submarine docking hatches, where they basically just, this cell expresses a certain kind of connexin protein. There's 6 of them. They sit in the membrane. The other cell does the same thing. They kind of go together like this, and that's it. Now they've got complex gating, so cells can open and close them. There's all kinds of complexities here, but it's a trick that evolution learned to make networks. That's what it does. It basically makes, when you look at models of artificial neural networks and those edges, right, that are between the nodes, that's what this is. These are basically those edges between the nodes, and the whole thing ends up trainable and larger goals and all that stuff.
Yeah, thank you so much.
Guy, I think you go next.
Sure. Thanks for the great talk. My question is, if you could say a few more words about how you kind of identify the change that is needed in order to have a certain effect. So I'm thinking of the example of the tadpole with the kind of notch mutation, where you figured out like what to induce. If you could just say a few words about that. Great.
Sure. Let me see if I've got all the slides here. I may not, but I'll just tell you the story. Okay, so here's what we noticed. Let's just look down here. So this is a rough voltage map of the early ectodermal tissues that are going to become brain. And one of the key things about this is that you can see a really tight voltage difference on the edges between these cells and these cells, which this is where that voltage difference is what tells these cells that's where the edge of the brain is going to be. Okay, the difference in voltage is what demarcates the boundaries around specific organs, right? So when we looked, we noticed that one thing that happens to all of these embryos when they get affected by toxins, by mutations, by many different things, what happens is that the edges get fuzzed out, meaning that the edges become really fuzzy. And you can sort of see that here. This is some quantitative data where the correct, if you just drop a scan line like this across the middle, what you see is that, you know, the voltage low, 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 high, low, 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 like that. And it's literally that difference between here and here that is necessary for the brain. So if everybody goes up here, it's terrible. If everybody goes down here, it's also terrible. It's literally this pattern that you need. So all of these defects come about by a flattening of this kind of in either direction, doesn't matter which direction, of this kind of thing. So we asked the model a simple question: if the gradient here becomes fuzzy, and so the difference is very small, how would we enhance that? So what you're really looking for is a contrast enhancer. If you're in Photoshop, that's basically a sharpen filter. If you work in the retina, that's basically edge detection. What you're looking for is to make that gradient much sharper. And the computational model found for us an amazing ion channel called HCN2 that has the following property. If your voltage is low, it leaves it low, but if it's even a little bit high, it cranks it up. So that basically, again, contrast enhancement, that anything that's sort of, you know, that kind of gentle low hill that codes for a bad brain becomes yanked upwards. The low cells stay low, the kind of slightly higher cells get jacked up, and in the end you get this pattern back, and that pattern is what's required for these cells to respond to where the edge of the brain should be. So what we found is the strategy that we're exploiting here is sharpening the voltage gradients between organ boundaries. Now, that's not going to, I guess, probably that's not going to be suitable for everything. There are going to be other reasons this goes wrong, and we'll have to come up with other strategies. But for a wide range of things, that works. And in fact, the wild thing is that we developed this strategy with very specific voltage data on the early brain, because you can see that the nice thing about the brain is right at the top of the tadpole, you can see it. So we have all these voltage data. We developed the strategy. 2 weeks ago, we published a paper showing that you can use the exact same strategy on the gut and the heart, where we have no idea what the voltage is in those organs because you can't see them. They're deep inside the embryo. We don't have any technology to see that, but that's okay. The exact same technique worked. So I think, as usual with these things, you can get out more than you put in, meaning that this is going to be workable across a range of applications. But there will be other things where the edges are not the problem. Some other thing is the problem, and then we'll have to go back to the model and invert the model again and ask how you solve whatever the other problem is.
Thanks. So to summarize, it's something. So you know, for the reasons that you explained, that a lot of the signaling occurs via like the bioelectric.
Okay.
Mental thing here, which drives everything else, and I'm going to show you, I'll go over a couple of the specific. I think the fundamental thing that we start out with is that biologicals and other things that may not be biological, but you know, we don't know, that what biologicals do is they don't take past experience too seriously. Now, I know this is a crazy thing to say for a biologist, you know, given evolution and everything else, but I think we need to think about the fact that the way that, you know, we have this, in robotics, we have the sim to real problem, right? Where you simulate and you simulate and you simulate, and then you make something, and then the simulation is never quite good enough. If you depend on what you did in simulation, it's always often like wrong and doesn't work quite right. And I think evolution, the way that evolution has worked is that it doesn't take prior experience too seriously, meaning it doesn't overtrain. When you have a genome, it isn't perfectly, at least in most animals. There may be exceptions. C. elegans or something may be an exception, but many animals, the genome isn't overfit on prior experiences, and now it knows how to do exactly that. It's a problem-solving machine. What does that machine have to do? As soon as the juice is turned on, so to speak, once it's going, it has to figure out what are the causal control knobs in my environment, meaning that what are the things that, with my limited metabolic and time resources, what are the knobs that make sense turning, in other words, by sending signals and so on, which means that it has to do things like causally coarse grain its environment. It has to adopt a kind of a predictive processing framework, in that it has to start to model itself as an actor, as doing things, as opposed to you know, a kind of a Laplace's demon, you know, sort of infinity of causes and effects. I mean, you'll be eaten in no time if you.
Okay, so basically he's just trying to explain to you that even on the cellular level, there is some type of cognitive understanding, cognitive conscious programming to where certain things will repair themselves without you even having knowledge that they needed to be repaired. It's just a built-in default system that's in there repairing things. And this goes back to using certain Arabic or holistic practices. Let's take milk thistle, for example. Milk thistle is very simple. It's readily found just about everywhere, I think, at least in North America, South America. I'm pretty sure it's in South America too, because the butterflies, that's what they eat, is the milk thistle. But you can take one milk thistle capsule. I've done this before, to help rejuvenate your liver. It has been scientifically proven to not only rejuvenate the healthy cells, create more healthy cells, but it also will rejuvenate the unhealthy cells within the liver. So it's literally helping the liver to rebuild itself, which it already does naturally anyway. So it's just like it gives it a boost, like an immune boost. And actually the Canadians, their paramedics, keep liquid milk thistle on hand in like an IV type fashion within their ambulances, so that if anyone has ingested poisonous mushrooms or something like that, they immediately give them the milk thistle to block the liver damage from happening from the poisonous mushroom that they just ate. And again, this is facts that you can go look up. This is common practice for them in Canada to use liquid milk thistle to protect the liver, because it'll protect it, it'll coat it, it'll help it to regrow dead cells. It will rejuvenate the healthy cells. I mean, it's a really amazing and easy to obtain thing. So, if you're intelligent enough to know what the herbs are good for, and you can take the herbs to enhance the already cognitive conscious function within your DNA on a biological level, then you're just amplifying and enhancing your already God-given abilities that are in the programming for how the body works. It's pretty fascinating stuff, really. Now, I want to leave you with this fun video. This guy's really great, Jake Ducey. If you don't know who he is, I highly recommend him. He's so full of love and truth and vibrance. And we're going to do this. We're going to listen to his telepathic techniques that you can practice at home. I love this so much because it reminded me of doing those what I called mind games, but it's really thought games with my children to teach them how to trust their psychic abilities and their intuition, telepathy, and all of that. Playing cards, guessing what's on the card in front of you, that someone is holding, or just holding the deck and feeling it with your fingers and trying to guess what card you're holding. Those are great exercises to try, and so is this. So we're going to listen to this now.
Okay, get ready to buckle your seatbelt, because in this video I'm going to scientifically prove how to manifest a text instantly from a specific person. This works like magic, and I'm going to show you the proof. So first, I just want to welcome you to the video. Good morning, good afternoon, good evening, wherever you are in the world. If you're new, thanks for being here. If you're a returner, thanks for coming back. Smash the like button on this video if you're ready to learn the secrets of telepathy, and check out my free success hypnosis right there down below. It's jakeshypnosis.com. It's my free success hypnosis to reprogram your subconscious mind. And what about this beautiful shot out here? What do you think? What do you think? Let me know what you think if you want to see more outdoor shots. Big idea number one, stop calling telepathy new age fairy dust. It's real.
Yes.
Scientifically, telepathy is defined as the communication of impressions of any kind from one mind to another, independently of recognized channels of sense. And since that kind of sounds like new age mumbo jumbo, hocus pocus, let me start this off with a quote from the Smithsonian Magazine. Smithsonian, the official journal published by the Institute of Smithsonian in Washington, D.C., where all the smart people are. And this is a direct quote from the research. Scientists prove that telepathic communication is within reach. So it's not just me saying it, and I'm going to give you a very powerful technique to do in just a minute. But first, let's backtrack to Duke University, one of the most prestigious universities in America. And there's a very famous individual, he was a professor named J.B. Rhine. And he was one of the first to do major studies on telepathy. So what he did was take a subject, put them in the Duke University library, and then he had a lab, the parapsychology lab at Duke. So he's in the lab, he puts the subject in the library, makes them face away so they're not cheating with special binoculars, and he gives them Zener cards, which all have different geometric shapes on them. And the individual is to tap into the collective unconscious mind and to predict what cards they're holding. Now, this is crazy. It's a statistical anomaly, but he actually ended up getting about 40% of every single one of the cards right out of over 1,000 attempts. Now, this is pretty mind-blowing, and it eventually led to the term you've maybe heard of. It's called ESP, extrasensory perception. Now, extrasensory perception was a term that J.B. Rhine invented after these studies that basically say extrasensory perception is you have your five senses, but then you have a sixth sense. The very first experience I ever had with that was when I was backpacking through Asia, and I actually fell. I was hiking in the rain on a little island called Lombok in Indonesia, and I saw my whole life flash before my eyes. I was just like an inch or two away from hitting my head, and I could have been dead in the middle of nowhere. Well, I wasn't gonna tell my mom what happened because it was really scary, but when I got back to my hotel, I already had all these messages from my mom. She was overcome by this feeling that something had happened to me. That's ESP. Okay, now that you know it's scientifically proven, let me tell you a crazy story so you know it works before I give you the technique. So Bob Proctor was my mentor and he was my hero. He was my favorite guy in the whole world. And he's the one that originally taught me about that J.B. Rhine study at Duke University that I was discussing earlier. So it was my birthday about 6 years ago, and I really wanted Bob Proctor to give me a call, give me some motivation and advice for my birthday. So here I am, I'm sitting in the car with my wife, Ashley, and I turned on a Bob Proctor audio seminar. So we listened to it on the Bluetooth speakers, and we're parked at the beach looking over the ocean. And I told Ashley that I was going to get on Bob's wavelength and then I was going to see if he would call me. So we're sitting there, we're drinking a cup of coffee, and we're listening to Bob. And I'm just getting on Bob's frequency. And I imagined that instead of listening to his seminar, it was actually him that was just talking to me. So I'm totally in this guy's energy field. So we're sitting there, we finish a cup of coffee, and then we start to drive to the gym. And some pretty crazy things happen. The seminar stops, the phone rings. We can clearly see on the screen Bob Proctor is calling me. I literally kid you not, my wife Ashley was there as a witness. On that drive, after doing that technique, I received a phone call from Bob Proctor. And I said, Bob, you're not gonna believe it. This is what I did. I just telepathically communicated with you. And he's like, very calmly, yes, Jake, I know I felt it. What's up? Well, it's my birthday today. And oh my gosh, we just telepathically communicated. And he's like, huh, that's the way ESP and telepathy actually works. You can communicate instantly and instantaneously because energy is never created or destroyed, and energy waves are transmitted instantly in the fourth dimension.
Because thought is faster than anything, including the speed of light.
Okay, so now it's time for the 3-step technique. And if you're wowed by this video, smash the like button on it. And it's important to follow these steps exactly. So step number 1 is to enter an imaginary scenario that would occur if you were actually communicating with the intended individual. So you want to see them. You want to see them calling you. You want to see them sending you a text message or some other traditional means of communication. Now, this is very important. You want to picture their faces and you want to see them very happy as they communicate with you, because we live in a reality of free will. So when you set the intention for it to be effective, then you're going to have stronger results if you see them happy, so you're not impeding on their own free will. Step number 2 is to hear their voice clearly. So I use that Bob Proctor seminar recording, so it would be an easy way for me to enter the spirit and vibration of that individual. So you can find an old audio recording, an old voicemail, or you can just use your imagination to hear their voice. So you want to picture the communication very clearly. You want to hear their voice. You want to feel the energy of their voice. Now, if you want, you could also do a practice where you and one of your friends watch this video, you get a recording of their audio, and you practice doing this technique and see if they can pick up on when you're trying to telepathically communicate with them. Now, step number 3 is super important. You want to imagine that you're actually getting goosebumps, or some people call them God bumps, as you listen to their voice. So imagine the sensation of goosebumps as you tell them, I was just thinking about you right before you contacted me. Step number 4 is once you effectively feel the energy, it's as if it's really happening. So you know the process is done. So you let go of it with a silent prayer of gratitude that the universe works in beautiful and mysterious ways. You might just say, thank you, universe, for the beauty and mystery. I know it's coming. So
Amen.
I'd love to feature your success story in a future video.
Okay, so I love his stories. I love his energy. So yeah, Jake Ducey, please go check out his stuff. And he has like really great self-help hypnosis for free and stuff like that. So yeah, totally go check his stuff out. He's amazing. I love to listen to him tell his stories because it reminds me of all of the stories that I have myself of teaching this to my children. Because when I had my first 2 or 3 children is when I was really like fully both feet in this discovery and research and scientific testing approach mode. And so my brother and I, we would do things together to experiment, and they would be fantastic outcomes. And I would be so elated and so excited that I wanted to show my kids. You know, little kids are like sponges. They love to learn. They love to be excited. They love to be around their parents, especially when their parents are happy and excited and passionate about things. So, you know, we would go out in the yard and we would play with nature, play with the elementals, and do things that were just fun and innocent, you know, totally safe for them, just enough for them to discover, you know, their wonders that are within them. Because we truly are treasures if we know ourselves. And this is why I say all of the time that if you truly understood who you are, you wouldn't have such a problem with the self-love scenario. So many people do not love themselves. But all of those reasons for not loving yourself, they're all on this societal based agenda level. And when you truly know thyself, it goes to this whole new big level where you're just like, oh my God, I'm like fantastic, man. I'm just fantastic, right? Like God made such an amazing creature or being or avatar or body or meat suit or whatever you want to call our human physical form in all of its glory. And it's so intelligently designed to be a proper host to our spirit, to our soul, as it sits within this body and they work in concert together, truly are symbiotic with each other. And I mean, I'm just like, I know what we can do, but I am never like, yeah, I knew we could do that ever, like never, ever. Every time I see it, every time I do it, I'm just like a little kid in the candy store or in a toy store. I'm just like so freaking excited and passionate about it because we are amazing. We really are. I mean, God, I hope I can get all of you to understand that someday so that you can really love us the way that I do. I sincerely mean that. So, I hope this video was informative. Please like, share, and subscribe, and tune back in because real soon we're going to have another video that shows more about collective consciousness and all of the amazing, wonderful things that we can do together. And scientific proof to back it up, of course, because that is the theme of these lessons right now, is to back up what we're trying to tell people with real scientific research and data. And the, you know, like that one scientist that was tasked to actually debunk the other scientists' work. And not only was he not able to debunk it, but he became passionate in helping to prove its existence even further. So I want you to be passionate about life. I want you to love who you are and what you are and run with that and play with that so that you can truly be happy and truly live a joyful life that really is for your highest good as God intended for us to experience. All of this societal control has greatly limited, and I say that in the minimalistic, most minimalistic way possible. It has greatly reduced our level of enjoyment, fulfillment, abundance in good ways, in all of the good ways, abundance. And one day soon we're going to get there and we're going to have that world again. I feel like there's many of you out there who still have that DNA memory within you of what it's like to have a peaceful place to live, a bountiful place, a joyful place, a place of passion, excuse me, passionate education, passionate learning modalities. And can you imagine a world with me, please, just for a moment, where our children are in an educational setting where they actually are excited to be there? And they're like little sponges, little scientists. They just can't wait to soak up more knowledge. and learn and try it, experiment with it, test it, see what kind of results they get. Children love that kind of stuff. I homeschool my kids, and the most exciting part about school is when we do the science experiments, because it's not just the basics of science, it's all aspects of science, all the way up to the metaphysical sciences, the noetic sciences. And they are just thrilled and excited to actively participate. It's so much more preferred by all children, in my opinion, than sitting at a desk with a book in front of them and having to read or do workbook pages and all of that kind of stuff. A real learning center where they can be actionable and interactive with everything around them to learn. Our children are going to be so much more intelligent and excited about being intelligent than you could ever imagine. I have 7 children, 5 of which are adults. All 5 of them have very high IQs, very high GPAs, because they were enriched in their learning. They weren't limited. They weren't limited in any fashion. I didn't keep them to a strict curriculum because of their age or the grade that they should be in. And I don't limit the amount of things that they can question or be inquisitive about or experiment on. Safety prevailing, of course. We are always very safe and cautious. But I encourage them to be enthusiastic. I encourage them to ask for something new to be taught to them. You know, if you want to learn something that I'm not teaching you yet, put your 2 cents worth in and let's make that happen. And they flourish doing that. They absolutely flourish in all ways. They know how to be more joyful. They know who they are better. They understand nature and the elements better. They can interact with others better. I mean, we learn everything. We learn about how to deal with emotions properly and the whole 9 yards, you know. Moral compass always intact. Education always at the forefront of what we're doing. And they thrive in that environment. So imagine if we took those principles and applied them to all children. What a beautiful world we would be creating, because they are the future. All right, food for thought. I'll see you again soon for more collective consciousness, scientific evidence. Until then, be well and be blessed. Much love to all.